Hi there, Mr. Sutton here. I've got the Pre-Cal Honors 4-5 Part 2 homework solutions on logarithmic equations. For this problem, we have a log on each side, which means since it's the same log, we can actually just cancel the logs, or you can think of this as raising the base 9 to both sides of the equation, which again would cancel both logs. So we can write 23 equals negative 5x minus 2. And then solving for x, we add 2 to the other side and divide by negative 5. That's going to be x equals negative 5. And just to make sure that this actually works, if we plug it back in, that's going to be, let's see, 25 minus 2. That's going to be a positive number. So we're not taking the log of a negative. Therefore, we are done. For this problem, I have a whole bunch of logs that I'm eventually going to need to get rid of. Let's start by merging the logs on the left side. Since we have subtraction of logs means dividing the things inside. So this is going to be log base 4 of 10 over 4x equals log base 4 of 74. Next, I'm going to reduce this to 5 over 2x. And since I have the same log on each side, I'm just going to cancel those logs out. So I can write 5 over 2x equals 74. Next, I'm going to do the old switcheroo, multiply by 2x and divide by 74, just so x is no longer in the denominator. Next, to get x truly by itself, I'm going to divide both sides by 2, so essentially doing 2 times 74 down here, which comes out to 148. So then I've got 5 over 148 for an answer. And if I plug that back in, the only place you can take a variable inside the log is this middle term here. And since I'm plugging a positive in there, this whole thing comes out positive, so I won't be getting any undefineds that way. For number 3, we have a log equation with an ln. That means we need to raise e to both sides. That'll cancel the ln on the left, leaving us with just x minus 2. And on the right, we have e to the second power. We still need to get x by itself, though, so we have to add 2 to both sides. And they said we could leave our answer in terms of e, so e squared plus 2 is good enough. For this problem, since we have 2 logs on one side, we're going to merge them together using log rules. Since I'm adding the logs, that means I multiply the things inside. So I've got log base 3 of x squared minus 2x, if I distribute that x, equals 1 now. To get rid of this log, I'm going to raise base 3 to both sides. So I'll have x squared minus 2x equals 3 to the 1, or just 3. Since I've got a quadratic here, I'm going to move the 3 over to the left side and see if I can factor this thing. So I have x squared minus 2x minus 3 equals 0. Two things that multiply to negative 3 and add up to negative 2. That would be positive 1 and negative 3. So that means that x equals 3 and x equals negative 1 are my potential solutions here. But we need to plug them both back in to make sure I don't have any extraneous roots. If I plug 3 in, log of 3 is fine, log of 1 is fine. If I plug negative 1 in, we're immediately taking the log of a negative number right here. So negative 1 makes the original undefined, and I have to cross it off. X equals 3 then is my only true answer to this problem. For number 5, we've got a double logarithmic equation. In order to get to x, we have to get rid of the outer log first. Since that's log 3, we're going to raise 3 to both sides. That'll strip away that outer log, leaving us with just log 5 of x on the left. On the right, we'll have 3 to the first power. Next, to undo log 5, we have to raise 5 to both sides. So we'll end up with x equals 5 to the third power, which is really just 125. For number 6, we have 2 logs to undo. To undo the outer one, we raise 6 to both sides. So that'll be log base 2 of x equals 6 to the first. And then we have to do 2 raised to both sides. So that'll be x equals 2 to the 6th power. So x equals 64. For number 9, in order to solve this log equation, we need to have at most 1 log on each side. So these 2 logs over here, I'm going to merge those together. Since we're adding the logs, that means we would have to multiply the x and the 6 to get them into 1 logarithm. So this will then be ln of 6x. And if you have the same log on both sides and that's it, you can actually cancel the logs out. Another way of thinking about it is we're raising e to both sides to get rid of the ln. Either way, we end up with x squared plus 8 equals 6x. subtracting 6x to get everything on one side because this is a quadratic. We can factor this now. This will be x minus 2, x minus 4. So that means we get x values of 2 and 4. And let's just double check to make sure these will both give us at least non-negative or 0 numbers that we're logging. So if I plug in 2, I'm not logging a negative or a 0. That's good. Same thing with 4. Both of these answers work, so we're done. For number 10, in order to solve this, I need to get these two logs on the left together. Since we're adding them, that means we can multiply the things inside. So this will just be log base 6 of x squared plus x. And then I'll raise both sides, or raise 6 to both sides to get rid of that log base 6. So that'll be x squared plus x equals 6 to the 1. We can move this 6 over to the left side now because we've got a quadratic. And to factor this, let's see, I would need x minus 2, x plus 3. Solving that now, we have x equals 2 or x equals negative 3. Let's check to make sure these are both legitimate answers. If I plug in 2, I'm not going to be taking the log of 0 or a negative in either of these, so I'm good. If I plug in negative 3, however, I'm going to be logging a negative after I evaluate the expressions inside these logs. Like the log of negative 3, that doesn't exist. So because negative 3 makes the original undefined, we're going to have to cross that off, and x equals 2 is our only answer for this one.